Hello guys, welcome to one and all. So this is I think uh, eighth video lecture or it's the video lecture. So in this video lecture I just going to cover this chapter, I mean electrical work, power and energy. So I had uploaded I think yesterday one video. So if you not watch, then first you go to see the lecture number 7, and after that if you come, then you will find more interest in this chapter. So yesterday, as I think I uploaded importance of physical quantity, what is the difference between mass and weight, and after that force, and second point is unit of work and energy, and third point is some causes of mechanical work or energy. So today we are going to just cover from point number 4. So without going to discuss on another topic, just come on our today's topic session. So today we are going to just cover electrical energy. So electrical energy, as I told you, energy, the SI unit of energy is what? Joule, right? So 1 joule is what? 1 joule of energy is expended electrically when 1 coulomb is moved through one potential difference, right? Is known as 1 joule. So as we know, V equal to W by Q. As we know, voltage is equal to work done per unit charge. So work is also known as energy. So from here we know W equal to what? V into Q. So here is same the thing. I mean what? Energy, electrical energy expended equal to V into Q, and its SI unit is joule. Now if we expanded Q equal to I into T, then again the energy formula is VIT. After that B equal to IR, as you also know. Then finally we got electrical energy expended equal to I square RT, and you know I square RT is also known as heat energy. So heat is also energy. So there are three formula of energy is given. First one is B into Q, second one is VIT, and third one is I square RT. So all this formula is really important. I think from starting to 8 I am just saying formula of this chapter are I mean any one chapter is too important regarding to our numerical problem. So now we have to just come on, I mean another formula. This is the fourth formula for energy. So as we know, I equal to V upon R. So when we put in value of I here, v b square upon R square into R into T, right? So R to R here cancel, then we find V square upon T into R, right? So this is the formula we found of what energy. So now we have to just think not think, we have to just know one more thing. 1 kilowatt equal to what? 1 kilowatt equal to 1000 watt per hour. 1 kilowatt hour equal to what? 1000 watt per 1000 watt hour, right? So this is can be, I mean expanded as we know hour. I mean here is watt hour. So in watt second or joule is 1000 when multiplied by 3600, then we find 1 kilowatt equal to what in joule. 1 kilowatt in joule is what? 336 into 10 to power 6 joule. Or in another sense, I think you can, I mean we are see in this form, the 1 kilowatt equal to 3.6 into 10 to power 6 joule, right? I mean in most of the book we find the formula, sorry, the value of 1 kilowatt equal to what? 3.6 into 10 to the power 6, right? Now the fifth point is thermal energy. So thermal energy is what? Thermal means heat, and this is energy means what? Energy. So thermal energy, the formula for thermal energy equal to m s into theta, and I can say, yeah, heat is measured into calorie, and when this calorie is have to measure in joule, then we have to multiply by 4.186. It's really important to know whenever calorie, or in other sense we can say 1 calorie equal to 4.186 joule, right? 4.186 joule. So whenever calorie is just converted into joule, then we have to multiply with 4.186 joule, right? Then calorie is converted into joule. So now we have to just common 6 point unit of power. So first is what, 1 kilowatt equal to what, as I also just above explain, there is given 1 kilowatt hour, but here is 1 kilowatt. 1 kilowatt is equal to 1000 watt, right? And mega means what, mega means 1 megawatt equal to what, 1000 kilowatt, 1000 kilowatt, and 1000 means 1000 watt. So when we multiply 1000 into 1000, then 1 megawatt equal to 10 to the power 6 watt. So whenever, I think in a simple way, in examination, this can be asked, 1 megawatt equal to how many watt. Then if you know, if you learn, then you can tick the your question within a second. There is no, you take time. If you learn very easily, you can learn very easily, right? So 1 megawatt equal to what, 10 to the power 6 watt. And now second point is what, 1 horsepower. It's also important, this can also ask in your examination. So 1 horsepower equal to what, 746 watt. 746 watt is known as 1 horsepower. Any Anywhere you hear 1 horsepower, your motor, the rating of your motor is 1 horsepower, 2 horsepower, then horsepower means what, 746 watt is considered as 1 horsepower, right? So this is horsepower. And now we have to just go on another uh, point. This is the 12 point, cell in series. So cell in series means what, listen, cell in series. So this is the cell which converted in a series, one cell here, after that end to end connection, then known as cell in series. So we have to find here current, right? So first of all, if when cell is connected in series, then total EMF equal to what, N into E, because one cell have EMF is E, but if we connect number of cell, then the EMF is N into E, right? And internal resistance of battery, here is the matter of thinking. Here is give, sorry, yeah, total battery EMF. Now we can't say here cell, because there are number of cell is known as battery. So total battery EMF is N into E, and total internal resistance of battery is what, N into R. R is internal resistance, and for number of cell is known as is multiplied by N. So now total circuit resistance is what, in external resistance plus internal resistance of battery, right? So now finally, what is the circuit current. So circuit current is what, as we know, I equal to V upon R. So V is what, there are number of cell is connected, so this is known as battery. So the EMF of battery is N into E, and external resistance upon in plus internal resistance. So finally, if cell is connected in series, then the current is what, the formula of current is this. It's really important, please try to learn. And the special case when capital R means external resistance is higher than internal resistance, then what, then we can neglect this one, internal resistance. So when we neglect this one, then we find, suppose when we neglect, then we find only this, right? So current due to one cell, current due to only one cell, right? Here we find. But instead of that, when external resistance is neglected, then external resistance, so when in external resistance is neglected, then here what, when we neglected, then we find n E upon n R, right? So n to n is cancel. So here is E by R, current due to one cell. Right? So finally, we what we got, what we get, in order to get maximum current in a series, in order to get a maximum current in series, the external resistance should be higher. When external resistance is higher, then we got a maximum current. But when the internal external resistance is lower than internal resistance, then we got lower current. So in question, it's a it's question it can be come like that. In if cell is connect in series, then what is the method to got higher value of current? So we, if we know, then we can simply tick, when the external resistance is higher than internal resistance, then we got maximum current, right? Maximum current for condition in series is external resistance should be high. And now it's parallel. Now here the cell is connected in a parallel. So same thing we can found finally formula. I just common a formula. We find the formula after deriving I equal to me upon mr plus r. Here is total value of EMF. Mr is internal resistance in parallel, and r is external resistance, and r is internal resistance. So the special case in parallel is what? When I mean internal resistance, when internal resistance is higher than external resistance, then what? When this one is sorry, when this one is neglected, then we find m e upon r, and m into current due to one cell. But when external resistance is higher than internal resistance, then what we find? We find me upon mr, then m into m is cancelled, then e by r, current due to only one cell we find. So here if we have to get a maximum current in parallel combination of cell, then external resistance should be low, external resistance should be low, external resistance should be low, right? So the cases, what cases is I mean happen here in, if we should have to get a maximum current in series, then external resistance should be higher than internal resistance. External resistance should be high in series condition, but in parallel is what? In parallel condition, what is given in parallel condition? In parallel condition r and r, this one is higher, this one should be higher, than we got a maximum current. So this is the video lecture for today's session, in which we have discussed, I mean what, unit of power, and thermal energy, before that electrical energy, and finally cell in series, cell in parallel. So I think we had covered more than 5 points, so it's really today topic is too important. So please, if you watch at last, then try to not forget to share it, because if share, and if you find any type of, I mean confusion or any type of question, then please comment. I would like to reply your any comment. So lastly, I would like to say thank you.